Welcome to Potter's Behind the Blades, not a podcast. My name is Stephenie Ravenscroft, and joining me is Josh Parent.
Hey, Stephenie.
This week we're continuing the discussions from the last episode on louvers. Welcome to Louvers 101, Part 2. Okay, Josh, let's talk about louver types, their unique features, how they are tested, and how these tests differ from one another.
Absolutely, let's do that. There are quite a few different louver types out there, but for this round of fun, we're going to focus on the most common, which are your drainables, your non-drainables, storm class, and AMCA 540 and 550 rated louvers.
Okay, let's start with the non-drainable louvers.
Sure. So first, non-drainable louvers. Non-drainable louvers are entry level. These typically have higher free area with lower pressure drop, which is great, but they most often offer very little in the way of water protection. A louver is considered non-drainable if the blades don't have provisions to catch and channel water out toward the jambs, which, as we talked about previously, are the louver side components.
And now drainable louvers?
Drainable louvers have built-in channels for water. Think about this feature like a gutter on your house. They function very much the same. Louvers at this performance level and above are designed and engineered to mitigate as much water penetration as possible, catching and channeling water along the drainable head, along each blade out towards the gutter and the jamb, and from there down and out the front of the louver. And most importantly, away from the inside of the building. These are great for most commercial projects as long as they aren't located along the coast.
Okay, we've covered non-drainable and drainable, so what's next?
Next up we have storm class. Storm class louvers handle anything comparable to, say, a thunderstorm, something having wind-driven rain. These louvers offer high water performance at the cost of reduced free area and increased pressure draw. With louvers, there is always some level of give and take when it comes to performance. That's why there's so many different varieties of louver available. Potterf alone offers over 80 varieties. And last but not least, we have hurricane-rated louvers, which are covered by some combination of AMCA 540 and or 550. These offer the highest level of water protection, but also come with the highest pressure drop too. So really be sure you're using them where they're needed.
You mentioned AMCA test protocols. Can you walk us through the relevant ones?
Absolutely. First up, water penetration, otherwise known as the still air test. Light rain, no wind, it's a very basic comparison. This test simulates a louver installed in the building with a functional HVAC system during a light rain event. The test outputs a beginning point of water penetration, which as a metric is used in building specs all over the world to determine when a particular louver model will start to allow water into the structure. From there, we move to wind-driven rain. Wind-driven rain offers both 29 mile an hour and 50 mile an hour wind speeds. In addition to wind-driven rain, which is blown at the face of the samples at up to 8 inches of rainfall per hour. This test simulates more of a thunderstorm condition and is quite a bit more aggressive when compared to water penetration. Wind-driven rain offers a water penetration classification as its performance output. Wind-driven rain is a much better recreation of a real-world storm event.
So in other words, a storm level test, where you're seeing how a louver behaves when conditions get messy and fast.
Exactly that. And finally, we have AMCA 540 and 550. These are the top-end projectile impact and hurricane simulation test AMCA offers. AMCA 540 is an impact resistance test where a 2x4 with specific length and weight requirements are launched from what's typically a pneumatic cannon toward the front of the fixed louver sample. During this test, we're looking to see if the various louver components will stay connected and within the louver frame as we look to avoid components becoming part of the destructive wind field typically comes with hurricane force winds.
Right, because the last thing anyone wants is a piece of louver turning into flying debris during a storm.
Exactly. And with AMCA 550, you're talking about what in the industry is known as high-velocity wind-driven rain. This test features wind speeds up to 110 miles an hour and incredible driving rain, which over the course of about an hour throws approximately 230 gallons of water at the sample. You pass that test if less than 1% of the water gets through. Keep in mind that's still approximately 2.3 gallons, and even 2.3 gallons really will create a mess inside your building.
That's wild. 110 miles per hour winds and essentially a small swimming pool of water hitting the louver. So passing that test is a pretty big deal.
Yep. These tests and resulting performance specs are very popular along the coast, all the way from Maine to the southern tip of Texas, especially in Dade and Broward counties of Florida, where you quite often need Miami-Dade NOA, its notice of acceptance, or listing with AMCA 512, which we will cover in another podcast.
So if you're working anywhere along the coast or anywhere with aggressive weather patterns, these ratings quickly go from nice to have to required. Here's the bottom line and the conclusion to this podcast. If you take one thing away from this episode, louvers aren't just about airflow. They're about performance, protection, and design. The next time you see one, know there's a lot of engineering behind the blades. If you'd like to learn more about louvers, visit us at www.podorf.com. Thanks for joining us for this episode of Behind the Blades.